We are in lesson 17, changing the base with logarithms, and we're going to look at problem number 22. But right now I'm on page 225 looking at the directions, and for this problem, number 22, we are asked to rewrite each expression in an equivalent form that contains only one base 10 logarithm, aka only one common log. So let me cruise on down to page 226 and look at our problem, number 22. Now what you might notice is I already turned this logarithm with a base of 3 and an argument of 81/100ths into its fraction equivalent, changing point A1 into 81/100. Now keep in mind though, I want to effectively turn this into only one logarithm of the base 10, which right off the bat, we don't have, but I can only use one common log in this explanation. So the first thing that I'm going to do is I'm going to turn this division problem into two separate logarithms, or rather use the quotient property of logarithms to separate this into a subtraction of logarithms. So when I use the quotient property, what's going to happen here is I'm going to get that log base of 3. I'm just going to copy this currently, make it a little bit easier, and turn this into log base 3 of our numerator, 81, minus log base 3 of our denominator, 100. And now what we've done is we have executed the quotient property to turn this into two logarithms. Now, the first thing I'm going to do from here is I'm going to work with my left part of my expression and evaluate log base 3 of 81, because really, again, what that's saying is 3 to what power equals 81. All logarithms answer exponential nodes. So 3, base of 3 to what power equals the argument of 81, and the answer to that is 3 to the fourth power. 3 to the fourth power is equal to 81. So really what that means is effectively we have simplified down this logarithm, log base 3 of 81, all the way down to 4. We have evaluated that left part of our expression. Now the issue is the right part of our subtraction problem. We have log base 3 of 100, and again, that's really asking 3 to what power equals 100. That's not going to be an integer. So what we're going to do is we're going to work to isolate down this by using the change of base, and the change of base formula says when I have a base I don't like 3, I could change it into a base that I do like common log 10, by turning this into a log of the numerator, the log of the argument as my numerator over the log of my base as my denominator. Now, really what we've done here is we have actually created a fraction. Notice I'm focusing only on this fraction right now. That's totally solvable. So just as a side, I'm going to move over here to the right for just 1 second because I'm kind of running out of room vertically. And I'm going to rewrite this log 100 as what we know it to be, log base 10, or 10 to what power equals 100. And log 3 is really 10 to what power gives us 3. That one we don't know, so we'll leave that in a second. But 10 to what power equals 100 we do know, and that's going to allow us to simplify down our numerator, log of 100, to 2, because after all, 2 to 10 to the second power is 100, sorry. Okay. Now what we have is effectively this problem that I am working with there, 4 minus 2 over log 3, and technically speaking, we have succeeded in writing this as an expression with only one common log. That's the log base 10 of 3 right there. Oh, there's our problem.